to the third programming challenge for the chapter 4. It's called the summing R series. So let's see the content. So we saw how to find the sum of series in printing a series on earlier page. So for those is for your convenience, if you can open my MindMind file, so I add our linkage from the point that the author mentioned to this programming challenge 3. So if you trace back from this link, so you can right click this line, then you can see go to this another block. So now this is the focus. If you click this one, it's come to here. Then this is the program the author mentioned that we have done before. So I also add our link here. So if you click this, it will directly open the file I put in the GitHub already. So what we have done for print the series before is we make our the inputs by user. So ask a user to give our the series or the expression. Then we send this expression to this print series. So this print series actually we have our expression here. But now we will have a certain enhancement. We will ask a user or the person who ran the program to give us the expression directly. So because now we are not only can deal with the symbol, individual symbol or multiple symbol, we can also deal with expression directly. So that is the enhancement. So we will try this first. So if we get our series, earlier is we use our for loop to make this series adding gradually. And then we will have this one. We ask a user to give us the symbol. Then we calculate the summary. But here, to support this programming challenge, the summation is our additional function that we can introduce here, which you can also get that from SymPy library. This summation is just to do the same way we did in the for loop, but they can just give us, we can use this for the looping parameters inside this summation function. So here is the changing part, or we can call that is the expression. Here is what is the variable we want to make the change, or which symbol we want to change. Here is we want to change n from 1 to 5. By default, the stepping is 1. So n is 1, 2, 3, 4, 5. Then for every n, we will add the solution of this expression, then make them grand total, and then use this pretty print. We can print this out. So that is, here is the x, n is 1, n is 2, n is 3, 4, 5. So and then after we have this s as the summation result, we can just transfer through the dictionary format our actual value to the rest of the variable. So now we only have x, so we will transfer x into this final the summation result, which is still our expression. And if you have a multiple the symbol still, then you can transfer multiple symbol within one the dictionary. So just to keep those symbol as a key and your value as the value. So that is the subs or substitutions we will use for get the actual result. So our challenge now is to write a program and capable to find the sum of an arbitrary series. So it's just our series which we ask a user to supply, and then this we make n as the variable parts, and then this no matter how many rest of the unknown symbols, we will replace n by the our list of the number. Then we give this result. Let's see. So what we can get from the programs. So we now go to here. So if we see from our mind map, this is 40402 is the printing series. You can back to this program to get some reference, but let's do this from scratch. So 04053. What is our putting is not printing our series, we will summing our series. .py. So purpose is summing an arbitrary series. Then let's starting to do the first part is the primary program parts is. Oh, sorry, you need to keep that in the small case. So key first part is we will have our this variable. So we can see so we call that is expression, just like our simplify. So when you use that, so now we know is we should from simplify import simplify. So that is one. So let's using this time is whenever we start to use one the class, then we load that. So simplify is we put that is input, enter one n term expression. So we don't need this semicolon. So then this number terms is equal to we will put that is int. So we will need is how many n the user want that. So we just need our integer. So yeah, enter the number of terms. So you can see here is either you can use both is double quote or single quote. So that is not our issue. So whenever is you have that pair, then what we have is we will have this find sum. That would be our function to be introduced. So is that then we transfer the expression and the number terms. Yeah, so it's terms. So now we have that is let's starting to build def find sum with expression and number terms. So what we will have is we will load this n as our symbol. But if we introduce like this A or D, we just use that into this calculation. So we don't need to define that. So n should be our symbol. So that is the number terms. We call that is just n. Now we know is we should have a symbol load. And so once we define the symbol n, then we can directly like use this way. So we can make our summation. Then if you want to use the summation, you need to load the summation here. So that is the another one we will use. So summation is we transfer the n n term, what kind of the expression. So we got, and then this the symbol is syntax is n with 1 and number terms, which is transferred here. So we have this summation. So I think we have that from SymPy we import SUMM summation. I think that's correct. So let's save. So we have this. Then this we also need pretty print. So finally, we don't need to return anything. We just is print this S. So that is our result. So let's do our test. So the test is using A plus n minus 1 times D. And the term, let's make 3. So 3 times A plus 3 times D. So it's the pretty print. So that is correct. So if I put this sum bigger, so maybe let's see, so A times A plus n minus x times D times x. So let's say I want n to 10. So now it's getting the a little complex because besides n, we have 3 variable a, b, and x. So represent that is from 1 to 10 of n to change. The rest of those is we also need to make them factored, or we can see is then this if they are the most simplest the format, we can get this as a result: 10 times a square, 10 times dx square, and 55 d times x. So that is the way. So no matter what kind of the expression you are putting here, it is okay. Definitely, is you can also use this try. So let's also have this one. So then, if we use that, is we also need to have this simplify arrow. And from here is we can kindly is to make sure is our let's see here. So this is the ensure is we input our valid expression, and we put this here. This n is fine, so we don't need another way to put that. So let's see. So if I run, n term is let's see. So I miss one parenthesis. It should be English function. So now first let me input n, and then let's see I put 5y plus d. So this is invalid thing that I got invalid, and then if I put n, then is I gave a plus n minus 1 times d. Then I got this one. So now you have this error handling to ensure you get the valid expression. So I hope is you can keep practicing is using the whatever you learned from previously. The way then is you can combine what you learned into the new program, making them is more and more stronger. So if you don't use try except else, the program you can see is still working, but it's not having those error handling the capability. But if you do that, is you can make your program a little more the beautiful. So that is the way. Is I hope you can keep your own practice offline. Next video, we will move to the last practice for solving single variable inequality. So we do this equality getting the solution, but now it's for the inequality, how we can do that. So I hope it's to see you in that challenge video. If you like my this video series so far, is welcome to follow my channel so that you can get notification for the new uploaded videos. Good luck. See you then.